Hello, everyone. Welcome to our research showcase. Uh, we final project focus on the water and ecosystems. Uh, there's three members in our groups. My name is Hao Qingwang.
and me, Yang Shuoshi.
My name is Mary Chen. Earth, as a planet shaped by billions of years of evolution, has undergone countless natural changes. However, with the intensification of human activities, our Earth has been termed the anthropocene, a defining characteristic of this geological epoch is the profound impact of human activities on the planet's geological ecosystems and atmospheric conditions. Today, we will explore how this phenomenal manifests in our surroundings. We will focus on two markers: change in biota and combustion. First, we examine the non-native invasive plant species. Non-native common red, which has spread near the chemistry building. These are the photos we took. Next, we focus on the geothermal technology project implemented in the dormitory buildings of the South Campus. These images were collected from UConn Today and the University of Shore website from the image on the right. It is evident that these infrastructures extend deep underground. Some may raise the questions. The Earth has undergone billions of years of change. Wouldn't it recover on its own? This viewpoint has some merit, but as we have learned in class, while the Earth's overall system may recover over long-term scales, human activities have already profoundly threatened the environment we depend on in about 0.1% of the Earth area. This locates the impact can no longer be ignored, and it even accelerating the pace of global change. Therefore, our research seeks to answer the question: how do human activities simultaneously have a profound impact on both ecosystem and the energy sector? By analyzing the spread of non-native invasive plants and the application of geothermal technology, we aim to provide a more comprehensive perspective on the underlying driving force behind these changes. In the Anthropocene curriculum website, biota refers to biological makers influenced by human activities, used to identify divisions of geological periods, including species extinction, the introduction and spread of new species, and ecological changes.
According to Adaptability, this is the distinction between native and non-native rates. While they are quite similar, native rates are shorter than the non-native strain and do not form dense monoculture habits. What, what we are observing is the rates on our campus exhibits this character, they form dense monoculture habits among cover the riverbank and clearly outcompeting the native vegetation. Therefore, there are considered an invasive species at the University of Connecticut. The native common race is native to Eurasia and was later introduced to North America. So it's balanced water and the other means it is tall. Colonial growth typically found in wetland, marshes, and coastal tidal areas. So the colony progression is spread readily, and its strong adaptability and repro re re reproduction context allow it to dominate many areas. Dispute wetland ecosystem and the strain negative species. The invention of non-native race can have multiple impacts on the wetland ecosystem on our campus. We illustrate this with a diagram. The top left, the green represent a health wetland ecosystem dominated by native plants with a balanced soil moisture nutrient distribution and rich biodiversity. The right side shows an area overtaken by rays which form monoculture habits outcompeting native plants, alter so mensured and nutrient distribution and affect wetland habits. Additionally, rice disparate water distribution reduce water available. Next, look at our second marker. On the Response Q commonly website, com com combustion is considered one of human major environment impact, particularly through the control of fire. Early humans used fire to alert their diet and social stimuli, and the in industrialization process further intends this change. The burning of fossil such as coal and oil release large amount of carbon dioxide and other greenhouse gas contribute to global warming. According to the university website, the planning for the South Campus infrastructure improvement project was complete in 2015. The project aiming to provide antitative support for the South Campus dorm and achieve South ability through the expense of cooling plant and the introduction of growth mode system. The project was implemented in August and is now complete. And this suitable technology expect to be optional by 2025.
The project director Elizabeth with background in the geotechnical and environmental engineers states that geothermal heat exchange is major renewable energy technology. It underlies the stable natural temperature gra- gradient underground for efficient heat exchange, storing heat in summer and extracting heat in winter. It is highly efficient, renewable, and effective in reducing carbon e- emissions, making it the environmental friendly and cost-effective in an energy solution. In fact, the traditional geothermal technology operated source hydrothermal systems where water is injected underground as the heat transfer field absorb heat from medium temperature permeable rock lower before being pumped back to the surface for power uh, generation. The success of the technology release uh, sufficient heat, water resources, and rock permeability, limiting its application and its posing its limitations. However, our University of Connecticut's design is more modern, using a group loop heat exchange system combined with expanded cooling plant and supplementary climate control resources. This makes it far for more environmentally friendly compared to fossil fuel combustion and the traditional geothermal technology. Follow our cameras as we take a look at the South Campus dorm area. It is now housing students, but just a few months ago, this area was still under construction with the completion of the project. The introduction of the geothermal technologies is in infrastructure will further improve in energy efficient and reduce the carbon emissions. It looks forward to these technologies fully realizing their potent potential in the coming years. Sets an example for campus sustainable. Uh, Source overseeing the non-native common read and geothermal technology project, we found that the University of Connecticut is the true microcosm of the issue. Human activities, both the threats and to ecosystems, while sustainable technologies demonstrate demonstrate the potential to address uh, the crisis. This reflects the dual impact of the human activities on the environment and remains our us of the need to seek balanced development in the future. We also comment that the university manage and control this invasive spaces. And what about you? Are you are there other similar signs on campus or the surrounding area? This is something worth thinking about the algorithm. And this is our references. Uh, this is our group presentation. Thank you for watch.